Hello everyone, welcome back to Java Academy. This is part 2 of our series on the most common Java mistake that every developer should avoid. In part 1, I covered about Java naming convention, proper access modifier, too many parameters, ternary operator and exception handling. If you have not watched part 1 yet, I highly recommend to watch it first because it lays the foundation for today's discussion. Now let's continue with the remaining mistake that every Java developer should avoid. And our next mistake is cognitive complexity. And many developers think cognitive complexity is related to performance. But that's not true. It simply measures how difficult your code to understand. So let's look at the real-time pseudocode. And this code is written by one of my senior fellow. And you can see here, Sonar is reporting code smell issue, refactored this method to reduce its cognitive complexity from 38 to 15 allowed. So what does it mean? It does not mean this code will not work. It does not mean your application will not work. It simply means this method has become too difficult to understand and maintain. And when another developer will open this code, they have to spend good amount of time to understand all this looping, nested logic and all other condition. And that's exactly what cognitive complexity measures. Now let me explain this with a much simple example, and you will often see this kind of code in real world projects. So suppose I want to calculate interest rate based on account type. So let me create one method here, public double get interest rate, and we'll pass one single parameter string account type. Now suppose if your account type equals to saving account, you will get 4.5 rate of interest per year on your account. But if account type equals to current account, you will get 5.5 rate of interest per year on your account, and so on. Now you can notice here, every time we introduce a new account type, we have to add another else if block, and as the number of conditions grows, the code becomes longer and more difficult to maintain. And this also increases the cognitive complexity. So instead of writing a long chain of if-else statement, we can easily replace this logic using switch expression. So let me replace this complete logic using switch expression. And now this code is much more cleaner, easy to read and easy to maintain. So this is not only way to reduce cognitive complexity, there are n number of ways by which you can reduce the cognitive complexity of your code. So just remember, the goal is not to justify SonarQube. The real goal is to write the code that's easier to read, understand and maintain. Now let's move to the next mistake. And this is also very common mistake which I frequently see in the real world project. Many developers compare string using equal operator, and they think equal operator compare string value, but that's not true. Equal operator is used to compare the object reference, not the string value or content. If you want to compare the content of two strings, you should always use the equals method, not equal operator. Suppose I have two string here, string s1 is equal to Java, string s2 is equal to new string Java. Now if I will compare s1 and s2 using equal operator, it will return you false, not true. So let me run this and let me show you the output. You can see even both strings have the same content. The equal operator return you false, not true. Why? Because equal operator comparing the object reference, they are not checking the actual content of the string. So always remember, if you want to compare the content of two strings, you should always use the equals method. Even after using the equals method, many developers still don't use it correctly. Look at this code very carefully. This is one of the real-time pseudocode. And now tell me, is there any chance this code could fail in production? The answer is yes. Now the question is, in what scenario this code can fail in production, or it will throw runtime error in production? You can see here, we have the string variable async task, and here I am calling the equals method on this string variable, and if the value for this async task is null, calling the equals method on null will throw null pointer exception, and due to that there is chance this code can fail in production. Now the question is how we can fix it. So instead of calling the equals method on variable, you can call the equals method on the constant, and you can see here this is the constant, the value is not going to change and it cannot be null. So now I am going to call the equals method on this constant and will pass this async task variable inside the equals method. And now this is considered a good practice. And why? Because even the async task is null, you will never ever get runtime exception in your production code. So this is a small habit, but that can prevent unnecessary runtime error in your production. Now let's move to the next common mistake that every Java developer makes. So many developers try to add or remove element from a collection while iterating over the list, and this can cause runtime exception in your production code. So suppose we have a list of names and we want to remove one of them while iterating over the list. So let me create one list which contains 3 names, and first name I can add as Govind, the second name I can add as Hari, and third name I can add as Prince in this list. Now I want to iterate over this list using for each. So we'll write string name colon names. Now while iterating over this list, suppose I want to remove Prince from this list. So for that we'll write here names dot equals Prince. If the name is equal to Prince, I want to remove from this list names dot remove. Now if anyone look at this code, at first glance it look perfectly fine, right? But if I run this Java code now, it will throw an exception. So let me run this and let me show you the error first. You can see here we are getting concurrent modification exception. And why does this happen? Because while iterating over the collection or list, we are trying to remove the element, and Java detects this is a structural change in the collection, and due to that it throws concurrent modification exception. So now you might be wondering, does this mean we can never add or remove element from a collection while iterating? The answer is no. We can still add or remove element, but we need to use the correct approach. And for this kind of operation, Java introduced the remove if method in Java 8. So let me replace this code with remove if, and now I will write names dot remove if. Now we need to pass the predicate name dot equals Prince. Now you can see here this code is much more cleaner, easy to read, and it will safely remove all matching element without throwing a concurrent modification exception. So always remember, if you want to remove any element from a collection while iterating over it, call the remove if, don't call remove method. Now let's move to the next common Java mistake that every Java developer makes, using collection without generic, and that is also known as raw collection. Even Java allows us to use the raw collection, but in modern application they are considered as a bad practice. So let me show you one example here. So let me create one list here. List is equal to new array list. Now let me add some value inside this list. So we'll add first value as a Java. Then I will add 10 inside this list. And you can notice one thing, I have not specified any data type for this list. And because of that, Java allow me to add a string and integer in the same collection or in the same list. And if I run this code, it compiles successfully and it does not throw any exception at all. So now the question is, what is wrong with this code? So the real problem will be start once anyone start reading the data from this list. So suppose I want to read the value from the first index, list.get 1. Now you can see that still this code is getting compiled successfully. But now if I run this code, it will give you class cast exception error. So let me run this and let me show you. You can see here we are getting class cast exception error. And why I am getting that exception? Because the second element inside the list is integer. And when we try to typecast integer into a string, it throws class cast exception. And this is the reason why raw collection are considered unsafe. So to fix this kind of error, instead of using raw collection, always specify the type using generic. So now let me convert this list into a string list, and as soon as I specify string here, you can see that I'm getting the compile time error here. And why? Because now Java know that this list can store only a string object, not the integer object. So the compiler catches the mistake immediately even before we run the application. And this is one of the biggest advantage of using generic. And in real world project, you will often see this kind of exception while reading the data from the database or working with legacy code that uses raw collection. So always use generic type and try to avoid raw collection in your real-time project. Now let's move to our final common mistake, using system.out.println for debug or logging purpose in a production application. And when you are learning Java, using system.out.println is completely fine. But in real production application, you should always avoid system.out.println and use a logging framework. So let's understand this with a very simple example. Suppose you want to log a message on your real world application, payment successful. So this statement print the message, but it print only on the console. But in production, application usually run on server, and relying on console output make it very difficult to monitor, search and analyze the log. So instead of using this system.out.println to print any log, use a logging framework like slf4j. So here I am going to import the annotation of slf4j log4j2. Now instead of this system.out.println, I will replace this code with log.info and will pass the same message, payment successful. Similar to this, if your payment got fail, so for that we'll use log.error, payment fail. Suppose you want to print some message while doing the debug, so for that we'll use log.debug, payment processing, and so on. You can notice here we are using the different log level. So we have the info, we have the warning, we have the error, and we have the debug. So remember, system.out.println is perfectly fine while you are learning Java or doing quick debug. But for production application, always use a logging framework, and it make your application easier to monitor, troubleshoot and maintain. So these are the 10 common Java mistakes that every Java developer should avoid. And if you found this video helpful, please don't forget to like, share and subscribe my channel. Thanks for watching. We'll see you in the next video.